So what I'm going to talk about today is the science of learning, technology, and transformation in higher education. So I'm going to start where I imagine good HCI people always start. Since we're talking about learning, we're going to start with the learner. So I work in I'm kind of an outlier in the Graduate School of Education because I work in higher education. Most of my colleagues work in K-12 education. And I work not just in higher education at Stanford, but I work with institutions of higher education of all what we would call Carnegie classifications, mostly across the country, but to some extent internationally as well. And one of the things that every institution of higher education is observing is the task that we're being given, which is not only to educate more students, a larger number of students in higher education, but a greater diversity of students. And I don't just mean diversity in terms of racial, ethnic, cultural, religious, gender identity, sexual orientation, all the different usual classifications of diversity. Those are all important, but also diversity in their background knowledge, their relevant skills, and their future goals. So how many of you are teaching right now in higher education? Okay, so one of the things you may have observed is that in your classes, the students that are coming into your classes not only have varying degrees of preparation for what they need to be able to effectively do what you need them to do, so their skills are varied, but also their goals, the reason they're even sitting in that class. So we have this incredible diversity in the needs, goals, abilities of the students. The other diversity, which we study more of here at Stanford, is also the meaning that they make out of the learning experience you give them. So you can't just sort of say, if you do this, then the learner will make this meaning out of it, because that's very complex, that process. So we need to look at all of this diversity. Now, how many of you have heard about educational, I guess, infighting or arguments about what's the most effective way to teach someone something? So if you haven't heard, I'll give you a little insight into some of these arguments, because you'll hear them a lot. One of them is, when you're talking about teaching someone like, I don't know, computer science, is it better to give them some basic instruction, a lot of practice doing the basics, or is it better to give them really complex, challenging tasks so that they get a deeper conceptual understanding? Like, that's a kind of dichotomy that is often presented. So which is better?
It depends.
It depends, okay? So then once you decide,
every social science question.
That is the answer. See, Michael knows social. It depends. So, you might say, but you have to make a choice. Like when you're designing something, you have to make a choice. So you make a choice. Let's say you say, I'm going to give them more help with the basics. Then I have to decide, how am I going to give them help? Am I going to give them focused practice, distributed practice, gradually widen the practice? So I have to make that choice. Once I decide I'm going to give them help with the basic, focused practice, then what kind of practice am I going to give them? Am I going to give them worked examples to study? Am I giving them problems to solve? Am I going to do some kind of interleave blend? And so on. I won't run you through all of this, but the point is that any choice you make quickly grows exponentially. All those little micro decisions you have to make to decide how to personalize the learning to that learner. So if you imagine, as an instructor, you're making this decision very rapidly for not just one student, but for this big diversity of students I was just talking about. So that's kind of a challenge. So what a lot of people are talking about is that our current processes for doing that, the way we've done higher education for years, doesn't really work anymore. And my argument, whenever Inside Higher Education or the Chronicle of Education or any of those newspapers write about my work, they always have some kind of headline, which is, she's trying to replace us with computers. And I used to respond to that in the following way. Frankly, any faculty member who can be replaced by a computer should be. But it didn't exactly have the impact I was hoping it would have. People didn't quite understand what I meant. What I meant was what a faculty member does is so complex and nuanced that if all they're doing is what I can do with a computer, then actually they should be replaced. What I meant was also that the tools, the tasks that we're given as faculty to do is not doable with the current set of tools. And in higher education and other institutions where there's these increasingly constrained resources, collapsing time, collapsing resources, greater diversity of students, more students achieve these outcomes in this different resourced environment, it's an unfair task unless we have better tools and supports for the learners and for the instructors to do that. And that's, in essence, what I'm trying to build, as I think I learned today some of the students in the seminar are also trying to build. So I imagine you have been thinking about this question. People talk a lot about technology and how it's going to transform education. And so I want to just take a poll of where this group's thinking is around what's going to transform education. And usually when I ask what the big power of the technology is that's going to transform education, I get one of three answers. These three. The first one, this is the big MOOC phenomena, right? Access and convenience. With a computer, learning online, you can learn anytime, any place. Huge transformative power. Access and convenience. Other people, especially people who've been watching my work, say, no. It's about this. It's about that you can do things with a computer that you can't do in a human classroom system. Like if we're trying to teach someone how to build a bridge, we can put them in a really great simulation where they build the bridge, it collapses, nobody dies, but they can have that experience. Simulation. The third one is, now Candace, it's not about the individual and interacting with the computer. It's about that these computers are connected to the internet. And by connecting to the internet, it's about connecting the learners to other learners, connecting the learners to other experts, connecting the learners to the world. So now I'm going to make you guys vote for one of these. If you had to put your money on which of these is the big power, the big affordance of the technology that's going to transform education, what would you vote?
Whose education, sorry?
Higher education.
Like in the US?
The US, you can define the context. Okay, so how many people think it's access and convenience? That's the big power. Okay, how many people think the simulation capability? Okay, great. How many people think, no, it's connection, crap. Okay, we've got nice distribution here. How many are thinking, wait, I thought Michael said that you were from the Graduate School of Education. Why are you giving us a crummy multiple choice test? How many of you wanted to say all of the above? Okay, how many of you just don't raise your hands when you're asked to raise your hands? Okay, how many of you wanted to say none of the above? Okay. Me? Yeah, actually I say all of the above and none of the above. But I'm interested, what's your none of the above? What's the power that I didn't mention?
Oh, well, what if you could make education free? What if you could pay people to study?
Okay, so open, free, yeah. I kind of boil that a little bit into access and convenience. Anything else? Yeah.
Add simulation and experiential knowledge.
Experience what?
I mean, simulation and experiential knowledge.
Okay, simulation and experiential knowledge. Okay, so you guys are refining some of my categories. That's great. Okay, so I agree, all of these are important, but actually this isn't the biggest, I don't think this is the biggest power. The biggest power of this technology is what Google has already figured out. It's what Netflix has already figured out. It's what Amazon has already figured out. The power of this technology is not using it to just push it out to people, but to push it to the interface. Why? What can we do at the interface? We can observe the learner. Netflix, Google, Amazon, they are observing us in their interface all the time. Why? Why does Google care what I'm doing in the browser interface? Yeah? To customize.
To sell ads.
To sell ads, yes, those two things. To learn about me as a consumer. Both me as an individual consumer, so they can target product at me better, but also to learn about consumers in general, so they can come up with better marketing strategies. So I'm talking about using that same approach, but not looking at learners as consumers, looking at them as learners. So in the interface, we can collect data to observe the learner, to understand the learner better as an individual, but also to understand learners and learning collectively better. That's the power of this technology, that we can collect the student interaction data and drive very powerful feedback loops to multiple actors in the teaching and learning system. So back to the learner, back to the instructor, back to the designers of the technology, and then back to the learning researchers. And I'll just quickly give a little example or power of each. So with the learner, we know that, for example, one of the things we know from learning research is rather than just lecturing at learners, giving them a goal, giving them directed feedback, and giving them practice enhances learning. So we can give them all kinds of interesting, authentic tasks, give them feedback based on how they're performing across multiple tasks. We can also not just do it to build procedural skills, but also to build conceptual understanding, like being able to take a bunch of discrete skills, synthesize them, and apply them in a new context. This is in a chemistry course, but I'm not going to go into great detail because I want to get to the discussion part. The other feedback is to the instructor. So if a learner is interacting with well-designed learning activities, and we're collecting the data from the students' interactions, then we can model that data to give the instructor insight into where their students are. So the instructor can use that information to plan their class time. Does that make sense? So the first, and just this is what we're going to be working on a little bit later, but our first attempt at doing that when I was back at Carnegie Mellon was to build these instructor dashboards. So this is an actual instructor dashboard generated off of an introductory statistics course. So, and this is a dashboard that's from an actual class. So the first thing is this module had 6 articulated learning outcomes. And the bar to the side of the outcome tells the instructor for your class what's our prediction about the knowledge state of your students. So green would tell us they got it. If you were to give them an assessment today, they would nail that task. Orange says it's kind of moderate. Red says they're struggling. They don't get it. What do you think gray means? Not yet attempted or not attempted enough. They haven't done enough for our modeling approach to make a reliable prediction. They could have done some tasks. They just haven't done enough. Yeah?
Just to make sure I understand sort of the boundaries of what this could do, because I love it. I'm just reflecting on my own teaching in sort of a design studio course. Mm-hmm. In some ways, it might be similar to like an English course where maybe the learning objective might be something around like understanding, Thoreau's relationship with X. And it's not the kind of thing where like simulated exercises can. First of all, you can design them, but they're indirect and hard, and you can't get a lot of them. So I'm wondering, what opportunities are there for these much more sort of indirect learning goals that can sort of be observed, but maybe only sort of at a larger project level?
Yeah. So did everyone hear Michael's question? Okay, so I would push back on you in a couple of ways.
Good.
One of them is when you say, I want them to understand whatever it was you said.
I can make one that's, so for example, in a course I'm teaching now, one of the explicit learning goals is to help students go beyond what I would call surface level need finding, where when they engage with users, they come back and say something like, oh, the button needs to move. And instead saying, why are they using that system in the first place? What are their needs, et cetera.
Okay.
And that can be observed when they come back with need finding results. But if I were to produce some sort of multiple choice quiz, so the answer is always obvious. Like if I told you, once I tell you the point, you know the point, but the actual proficiency at it is much more difficult to achieve.
Okay, does everyone hear that? So what I would do with Michael, if he were a faculty domain expert that I was working with, is I would, when he comes at me with a understand learning goal, we would need to unpack, what do you mean by understand? I will say that I was involved in a project with the Carnegie Foundation up the street, developing this Statway courseware for students who are placed in developmental math and an alternative pathway going through as statistics as the terminal course instead of. And so they wisely brought together multiple faculty from multiple institutions to define the learning outcomes. What is it by the end of going through this course we want students to be able to do and know? And they had 3 meetings, 2 days each, to bring faculty together to articulate this. I, unfortunately, because of my travel schedule, missed the first 2 meetings, but was there for the 3rd meeting. And by the time I showed up, they were like, oh, it's great, we've got it done. We've articulated the learning outcomes, now we can just start talking about design. I'm like, great, can I see them? Can I see the outcomes? And they were things like, understand medians, understand modes of center, models of center, the definitions of center and spread. Okay, great. So can I ask, what do you mean by understand? Do you all know what you mean? Oh yeah, we've talked about it, we know. So then I started to ask, okay, so when you say they understand measures of center, do you mean that if you listed a bunch of terms, they could say which ones are measures of center? If you gave them, could you ask them what are the 3 major measures of center and how would you define them? Is that what you mean? Yeah, that would be great. Okay, great. Is that what you mean? Well, no. I want them to be able to, recognize when you'd use a mean versus a median versus a mode. Okay, that's different. Okay, so being able to clearly articulate what the learning goal actually is. And then some way to get at that is, how would you observe it? So sometimes what I do with faculty, when they can't get past the understand, I'll say, append a so that. Understand so that, and you gave me a so that. So then we can start to develop tasks, not necessarily multiple choice questions, but tasks that we can observe movement in an interface that would collect evidence about the degree to which the student had achieved that outcome. So one of the differences is like in Khan Academy. I'll pick on it. They say they have a particular idea about how to assess mastery or competence, which is usually so let's say the goal is the student should be able to compute the median. I'll stay with my statistics example. So they'll say, okay, I'm going to give you 10 arrays of numbers, and I'm going to ask you for those 10 arrays of numbers to compute the median 10 times. If you get it 8 out of the 10 times, or 8 in a row, I'll say you know how to compute the median, move on. Okay, so that's one way but that's it doesn't get at what you're talking about. Because what we really mean is, when we say we want to make sure a student can compute the median, is that, yeah, they can compute the median. But you want to know, can they recognize, if they're given a data set and they're asked some questions, do they know when computing the median is going to actually help them make traction on answering the larger question they're trying to answer? So can they use computing the median as a tool? Do they know when to use it? Then once they say, okay, I should compute the median here as opposed to computing the mean or the mode, then do I know how to compute the median? Or do I make some common mistakes, like I forget to put the numbers in rank order before I pick the center number, or whatever the issue is, or I mistake the median for the mode, or whatever. Then once I've computed the median, do I know what to do with that number? to make meaning on my original task. So those are all three what I would call knowledge components that get put into a really simple articulation of compute the median. And what we would do in the kinds of courseware that I'm developing is we would give students multiple opportunities in all kinds of tasks where compute the median is a sub-step. And we don't say, okay, now we're computing the median, can you do it? We just observe. When they get to, it would have been logical when they're at that point in trying to solve this more complex task that what they would do is compute the median. And whether they do or don't, or whether they ask for a hint, or whether they, what they do, then we get insight into where they are on that learning trajectory of achieving that outcome.
And what about scenarios in which, I'm going to call this, the assessment is expensive in some way, and that, I don't mean money, I mean that either it takes a student a long time to answer whatever this thing would be, so it might be difficult to get a good estimate of their understanding, or that it's hard to assess what they have produced. So it takes, maybe it requires someone with a lot of expertise in the area to manually label it. Are there ways that you've played with that can...
Okay, so this is one of the areas of active research, right? So our approach historically has been getting together domain experts with learning researchers, with software engineers, with data modelers that all work together to co-construct the intervention and then think about what evidence does that produce. But the real power is if you create these kinds of activities intentionally that way, then you can have, as I do, thousands of learners using them in all kinds of different contexts, and you can begin to use the data to start to answer some of those questions. So they might be expensive to produce on the front end, but then on the back end, on the wide use, then the per student cost gets very small.
What we've observed, like with Chinmay's work and else, is like in a design task, for example, learners do not always have sufficient mastery to be able to recognize when another student has succeeded at a task, which makes the evaluation of the assessment actually difficult to scale. Right. Which means that I can't easily get these bar graphs, and maybe I have a lack of creativity here, and I wish I.
Yeah. So this is great because this is like where we can get some active research. So the thing that this was our first representation. So the way that this prediction is made is there are all these different activities that are designed for which. That larger outcome, relate measures of center and spread to the shape of a distribution and choose the appropriate measure in different contexts. There are multiple tasks and subtasks throughout an entire module where the student didn't necessarily know, but the system knows that's what we're looking at. So it's sort of semantically, that task is semantically tagged. And so then we can make a prediction for where your class is, but also where each student is. But that has everything to do with how well does our predictive model work. So the other thing that we do is the first model that we build to make these predictions, that we use the experts and so on to build, we call that a naive model. Because it's just what the domain experts, the learning researchers thought the association was between those tasks and the prediction.
This would be something as simple as saying, here was a problem, it required these skills, so if they got it right, there's some evidence that they got it right.
That's correct. And there's an underlying, which we'll talk about in a moment, there are different ways of, we're getting into knowledge tracing now, and there are different models you can use to trace knowledge. So for this one, we were using a pretty simple 4-parameter Bayesian knowledge tracing model, a hidden Markov model. And but there are other models that people put forward that they believe will make better predictions. So in the new system that we're building, that the model is interchangeable, but we'll talk about that in a minute. But yes, so that's, and then once we get all this data from thousands of students using these activities, we can then look at how well does our model fit the data. And then recognize where there are places where the model needs to be updated. Like, for example, if we'd labeled a bunch of tasks compute the median, but in fact, where they were struggling. We do like a learning curve analysis, and we could see a nicely downward sloping learning curve and then an inflection point where it flattens out. Then you could say, okay, what's going on there? Oh, that's not really just compute the median, that's recognize when to compute the median. So then we can unpack and refine the knowledge model.
And naive question. A downward sloping learning curve, to make sure I understand.
Oh,
as the x-axis is going up, this is now you have like better students to the right, worse to the left?
No.
Okay.
So a learning curve, a classic sort of learning curve, is the y-axis is the amount of assistance the learner needed in order to achieve that task. The x-axis is the number of opportunities to demonstrate that task. The knowledge component, what we call a knowledge component. So if you think about it, what you really want is a good learning curve is one that starts high and then slopes nicely downward. Because what that means is when that learner was first confronted with a task where they needed this hypothetical knowledge component in order to achieve it, they needed a lot of support. Either they tried answering it, they got feedback, or they asked for a hint or something. And then over time, as they were given more and more tasks, opportunities to demonstrate that knowledge, they needed fewer and fewer supports to demonstrate it.
So X is T, is time.
Yes, X is opportunities, number of opportunities, which is in theory, yes, in time.
Thank you.
Sure. And so anyway, so what you can do is start to look at how well does your predictive model actually fit the data and look for these inflection points or these flattening out points where you know you need to refine your model. Okay. So I'm going to skip through all of this because I want to get to, so this is like, oh, actually, I'm not going to skip this part. So what I said was in the old system or in the current system, we bring together these development teams. But then we also, now, as I said, have hundreds of faculty that are using these courseware to support their teaching. And when I developed the system at Carnegie Mellon, we did not have authoring tools. So the kind of choice was use what we designed or don't, or join our development team and add stuff. And so one of the things that we have in moving to OpenEdX here at Stanford is authoring tools. But that then created this additional problem, which is now people make an instance of the course, make their modifications, and it's, you know, so now we have like 50 different versions of the courseware, and we don't get a way of actually using the data to drive the continuous improvement. But I have a solution to that, which I'll not talk about right now. I'll talk about it later. Okay, then the science of learning, so the purpose of the science learning is basically just to describe, predict, explain human learning. And the particular sciences, the one that I used a lot when I was at Carnegie Mellon is cognitive science, taking these very complex cognitive tasks, like doing a data analysis or writing a computer program, and essentially deconstructing it into different components, and then building guided learning experiences with hints and feedback to support the learners. But then here at Stanford, I now have a whole new set of colleagues, so I look at things not just cognitively, but also social psychologically, like what's the learner's mindset and how does that intersect? We're doing some interesting research right now with inserting into the statistics courseware different experiments around mindset interventions, and also building affect detectors and timing the delivery of the mindset intervention, not just to the cognitive complexity, but also to the affective state of the learner. And that, again, will help us both refine our theory of how mindset works, along with helping learners actually learn. And then also issues of social belongingness or stereotype threat, which I don't have enough time to really go into in depth, but let's say other factors that you need to be looking at when you're looking at the learner as a whole person.
Without taking it too far out of that, I'm curious, are you modeling the level of stereotype threat that someone's experiencing? Is that your interest?
The interest there is this is more of a looking at the environment and say what are the cues, explicit or implicit in the environment, that trigger or mitigate stereotype threat to a particular learner. And can we manipulate cues in the environment that will address that?
The environment being your software system.
Meaning the software system. Yeah, I can't control yet. I can't control the whole learning environment, so the environment that I can control. I mean, a small example of that is just a small example of that is, in Facebook, when they used to have the icon they had of, was it Friends? Icon, it had a male and a female, and the male was in front and bigger, and the female was smaller and behind. And that little cue, I mean, I'm sure it wasn't designed in any way to communicate anything, but it does. And so if you manipulate those kinds of cues and signals in the environment, can you change the experience of stereotype threat? So it's just another lens to look at the design through. Okay. So, and this is, of course, data science. So now we have all of our learning theory, and then we have all of our new data tools, and we bring those together, the bottom up from data-driven, top down from theory-driven, with the subject matter experts to build better explanatory and predictive models that we use to design the environment. So I was going to talk about how we do learning research, but I'm going to skip that because I want to get to what I really want to talk about. Yeah, this is another. So what I was talking about is the data collection and analysis in real time. Another project I have, an NSF project, is to build the back-end data infrastructure to support learning researchers to be able to use each other's data and do analysis over multiple institutions. But I'll talk about that. And yeah, this is, the idea is that when we're doing learning research, we should be working in past year's quadrant. Is everyone familiar with this matrix? So this was a way of looking at science, that there are two dimensions, either science that has a high emphasis on basic science, on fundamental understanding, with a low emphasis on practical use. And if you're working in high emphasis on basic science, low emphasis on applied work, then you're actually working in Bohr's quadrant. This was kind of based on physics, so Niels Bohr's. So you're developing and understanding fundamental principles, but how you translate or use those in the real world isn't a focus. Or you could be working in Edison's quadrant, which is really applied. How do I solve this problem? With very little focus on what fundamental principles are we developing. So the problem there is, how do you solve this problem, but how do you get some meta understanding that would help you solve the next problem? And then there is this quadrant, which I didn't put a name on. It actually, Stokes did put a name on it. He called it Peterson's quadrant. Anybody know who Peterson was? He's the bird books, Peterson's Guide to North American Birds. No bird watchers in here. Anyway, it's low emphasis on basic science, low emphasis on applied work. It is essentially following the researcher's curiosity. That was the idea. I simply tell my students what NSF will not fund. So just stay out of that quadrant. And then where I believe learning research needs to be is up here in past year's quadrant, where we construct the interventions, we construct the research so that we are simultaneously making progress on our fundamental understanding of human learning at the same time that we're solving a real-world learning or educational challenge. And then this gets to the virtuous cycle that Michael was talking about, which is we start with our current learning theories and our current ways of modeling data. We use that to inform the design of the learning experience. We design the learning experience mediated by the technology to do what the technology does best, which is collect data. We analyze that data to refine our learning theory and models to redesign the environment, and we set up this virtuous cycle of continuous improvement. And that's my argument for why it's the data collection capacity that is really the big power that's going to transform education. Okay, so why does this happen in higher education? As I said to the lunch group, it's because higher education is in this enviable position in which the researchers, the practitioners, and those that are intended to benefit from the research and practice, the students, are all co-located. So we can rapidly design interventions, collect the data, and iterate very rapidly. And I'll just end with 2 quotes before I give you your task. The first quote is from, if you've ever been to Carnegie Mellon, you have to quote Herb Simon. He's like our little luminary. And he said back in 1991, improvement in post-secondary education will require converting teaching from a solo sport to a community-based research activity. Now, I modified his quote, sorry, Herb, to change it to improvement in post-secondary education will require converting teaching and courseware and platform and analytic system development from a solo sport to a community-based research activity. And my last quote is from another economist, William Baumol, who said back in 1967, without a complete revolution in our approach to teaching, we cannot go beyond our current levels of productivity. When I used to give this quote, I used to say, such a revolution is possible. Now I say, such a revolution is happening. It's not only possible, it's actually occurring. But my question is the same. If we're having this revolution, who will lead it? And it's kind of an embedded advocacy, which is, I think, institutions like Stanford need to be leading this in an interdisciplinary way. But we can talk about that. Okay, so that was all I was going to tell you. Before I give you your task to do you, any questions? Yeah.
So you kind of referenced this a little bit earlier, but obviously there's a lot going on in the ed tech space right now, you know, in industry outside of academia. You know, maybe you just answered this a little bit with your last comment, but what do you think of all that, and how do you see those industrial players playing into what you're looking at?
Okay, so did everyone hear his question? Okay, so I am both excited by and terrified by what's happening in the investment in ed tech world. For a long time, nobody was investing really in ed tech because there wasn't a lot of money in it. But now, because of these powers that we're talking about, it's being recognized that there is potentially a lot of money in it. So there's a lot of VC funding happening. And I should preface this by saying some of my best friends are venture capitalists. Some of my best friends are ed tech developers. So it's not that I'm dissing them, but I would argue that the major outcome driver might be not quite compatible with the major outcome goal of not-for-profit higher education. A lot of my friends that are VCs, when they're investing in these ed tech startups, they're looking for a 30 times return on investment. Why? Because they know most of what they invest in isn't going to hit. So when something hits, you want it to hit and return your investment. And most of them are not looking for immediate profitability. What are they looking for? What's the big marker right now? Anybody?
Revenue growth.
Pardon?
Revenue growth.
Not even market share. Like, how many people are using this thing because if we can get a big user base, that's where the money is going to be. So unfortunately, what it's driving a lot of my friends in the ed tech startup business is even if they have something that's kind of innovative and interesting, they quickly have to satisfy to the market because the decision-making process is still different. And so their innovation kind of gets tweaked and tweaked and tweaked and tweaked till it fits better what the market who's making the buying decision wants, which is not a recipe for driving innovation. It's a recipe for satisficing to the market. So that's one of my big concerns. The other big concern is that the data that we're collecting, the models that we're making from the data, and the predictions and the explanations that are extracted from those models support pedagogical decision-making in one of two ways. Either giving it back to the system itself how many people have heard of personalized and adaptive learning environments? Okay, so it's a big thing, making personalized learning and adaptive learning environments. What that means is from the interactions, as I was talking about, from the learner, then you model that, make a prediction about the learner, and based on that prediction, the system itself decides what to give the learner next. The challenge there, there are multiple challenges. One of them is to differentiate instruction, which is what we're talking about. You'd have to have some reasonable sense of on what basis, what makes this learner different than this learner for the purposes of this differentiation decision. And we don't really have, right now, a good taxonomy, if you will, of how factors about a learner, factors about the knowledge, factors about the environment interact in ways that would support a reasonable differentiation decision. You could argue that you don't need that anymore. What you can do is just get a huge amounts of data and just give it, and just train a learner, and in this case I mean a machine, not a human, train a learner on that data, and it doesn't have to be able to factor, to sort of define what the different factors are, it just has to make a very reliable prediction. So it doesn't matter what differentiates these different learners, as long as we can make an accurate prediction about what's going to give them, what to give them next to get to where you want them to go. The bias there, someone is working on bias and that I talked to at lunch. Anyway, the bias there is what data are you training the model on? And what are the outcomes that you're giving it to train against? So, you know, we see it in other sectors where we risk, if we're just giving huge amounts of data that is not representative of what we're trying to achieve, that we're going to instantiate in the learning processes all of the, and tool it in, all of the existing biases that are in our education system, and that terrifies me. What I think the real power is let's go ahead and train the machines to identify the patterns, but then we should critically look at those patterns and say, is that what we're really trying to reproduce, before we just give it to a system to instantiate that and replicate it and scale it. So, and I just worry that the motivation, what's driving, because I used to work in the private sector. Before I was an academic, I was in the private sector. And people always say to me, you know, Candace, it's not like commercial companies are all evil. There are some really good ones out there. There are ethical ones out there. And it's like, yeah, I know. But I also know, having been in the private sector, that the number one ethic that is return shareholder value. And that has to be the primary driver. And if you're not making that your primary driver, you are actually behaving unethically. And so when that conflicts with other goals, then I think it puts institutions in a hard, organizations in a hard position. Other questions? I'll try and be briefer. You just got me on my soapbox.
I want you to try to convince me that in all or most situations it's possible to develop a model of the learner and of knowledge that is intensely measurable. And I'll give you an example. If I'm trying to teach a class of musicians how to program, and my learning goal is that the students will be able to design in their mind some sort of interaction they want to have in a sound that's produced, and then through some means of programming, implement it without too much difficulty and have an intense satisfaction in what they've done. I could divide that into knowledge components, like students can identify where to use an array, and they know how to access an array, and they know not to go beyond the end of the array. But if I don't actually care about which language features they learn, I just want them to have a satisfying experience, I'm not sure how I would collect data on that.
Okay, so I'm going to respond in a couple ways. One of them is, and if I did say this, I misspoke. I didn't mean measurable. I meant observable. So measure implies ranking, that you can say this person's better than this person is better than this person is better than this person. So some kind of ranking that's implied in measurement. I don't need for the evidence I'm collecting to be able to allow me to rank order learners. But it does need to be observable so I can get insight into what are they doing. So that's my first thing. The second thing is, remember the headline? She's trying to replace us with computers. I'm not. What I'm trying to do is say there are things that the technology does really, really well. There are affordances to the technology. There are affordances to what a learner can do with their peers. There are affordances to what a learner can do with an expert. And they if you think of those as resources in a design space, they all have limitations and they all have affordances. And what I'm trying to build is, given the constraints of our current, whatever the context is in which you're teaching and learning, and those resources you can bring to bear, how do you make an intelligent decision about how to blend those different resources in a way that creates the best learning experience we can at that point in time for that learner, at the same time as learning something about how to make that design decision better next time. So I wouldn't try and, all those things that you're trying to achieve, I wouldn't say, let's try and figure out how to make a computer do all of those. I would say, let's take what parts of those is real, the learner is actually better supported, and we can get better information from mediating with the technology, and which things do we need to keep as a design that we do with the learners interacting with each other or with you as the expert. But I do think that we can do a lot more than what most people think. I think most people think all you can do is, if you can give me a multiple choice question, assess it right or wrong, that's what a computer's good at. There's a lot more you can do. Like one of my doctoral students who just got her PhD, she was working with the Poetic Media Lab here on this piece of technology called Lacuna Stories. And what that does is it allows literature, or anytime you have something you're reading, you load it into Lacuna Stories, and then your students, as they're reading, make annotations. Either by highlighting or by adding comments or whatever. And so what she was building was a automated system that could give insight. So we have learners using that at sort of Foothill De Anza, at Michigan, at Stanford, in all kinds of different classes. And one of the things, and so faculty can see where the hot spots are. That's some information. But the information was pretty overwhelming for faculty to try and parse and figure out, okay, what do I do with this to do something different in class with this new insight? And so we started to code annotations by whether they were reflective of a student making a reading comprehension kind of move, or a analysis kind of move. So like what the stance was of the learner, and could we train an algorithm to be able to automatically, with a high level of reliability, detect those kind of moves, so we can say to an instructor, you know, at this point in time on this text, this percentage of your students are still just trying to understand, comprehend the reading. And this is where, but no, now here they're moving into analysis. And you could have a trajectory over time where a faculty member could try different interventions if they're trying to move their learners from fewer comprehension moves to more analytic moves. And then you could tell, were those interventions actually helping move the learners along that trajectory? So there are other ways than just intelligent tutoring systems that we can use the technology to collect observable information to support teaching and learning. There's one over there. Okay, I broke my promise. I said I would answer short, but okay. So, okay, any other questions? Or should I give you your task? Because there is a task. Okay, because you guys are all HCI, you men and women are all HCI people, right? Men and women, and yeah, okay. So here's the group activity. Here's our goal. Okay. So give data-driven feedback to instructors on their student progress that instructors use to make informed decisions in their classroom. Okay, that's what we're trying to come up with. Okay, the student progress data comes from the OLI courseware and the OARS system, the Open Analytics system. The instructor is the user. And we want it data-driven, so we want them to use the data that we're collecting. And this is what the OARS system, the Open Analytics Research System, is that we built, okay? So it takes, right now in edX and Lagunitas Sue class here, we built an event handler that throws 4 pieces of information from every student interaction. It throws the student ID, the component ID, what thing they're interacting with, the time and date stamp, and a value between 0 and 1. it also sends the learner and course information ahead of time to the system. We have a skill mapping service where all of those components are associated with skills. The skills are associated with learning outcomes. And then that information goes into a modeling service where you can use different predictive modeling approaches, like Bayesian knowledge tracing, deep knowledge tracing. And then that output of that model gets sent to a learner activity recommendation service or a visualization service, which then either gets delivered directly out of ORS as it is right now, or fed back into the learning management system if the learning management system can receive it, to either adapt and personalize the learning or to present an instructor dashboard. Okay, is that clear?
And how long do we get right now to work on?
Okay, how much time do we have? Oh, no time. Oh, bummer. Okay, well, you can work on it and come see me. I want you to work on this. Because what the task is so I was going to explain how there are all these activities, they feed these skills, which then roll up to these learning objectives. Well, we're not going to have time to do this, so bummer. Okay, because this would have been a great...
With the thoughts so we can think about it?
Oh, sure. Okay, so this is just sort of showing how it goes. I was going to... Okay. So right now, I showed you one visualization. Another visualization that we came up with was this one that shows, this is like at the skill level. This is like a class of 225 learners. It shows us the number of activities done by the student is the x-axis. And then the number of activities done by the students who have not yet mastered the skill, that's along the x-axis, but the downside. So mastered, not mastered, up and down. And then why did we create that? Because what I was finding with the old dashboard that I showed you where we were just doing prediction is when we'd observe in the data how faculty were using it, they knew that we started off giving them the prediction about knowledge state, and they learned quickly where to find how many problems did the student do. So they would we could tell by the time delay, they weren't looking at that first display at all. They were just clicking in to find out what they wanted to know, which is, I assigned 20 problems, how many problems did the students do? So we were trying to come up with a different visual representation that would drive the faculty behavior, both support the behavior they currently have, but drive them towards different behavior, which is using evidence of student knowledge to inform their decision making instead of just their old measures, which are, how did you do what I told you to do? Okay, so, and we did this by asking them, what do instructors need to make informed decisions for class? And the instructor would say, I need to know if the students did the assigned 20 activities. Then we'd ask them, why do you need to know that? And then they'd say, if they did the homework, then they must have mastered the skill. If they did what I told them to do, then they would have learned it. And so then we'd say, so you need to know if the students mastered the skill. That's really what you're trying to get at. But even if they'd say, well, yeah, they still want that first piece of evidence. So one of the challenges that they need to first that we're discovering is that they first they need to know if students answered activities as an estimate of whether or not the students have mastered an assigned skill, but we have other more accurate ways of estimating this for them. So why do they still want that? And one theory is that the dashboard they're not convinced. They don't really believe that it makes a better prediction that they would make, which I wholeheartedly agree with that skepticism. And that's why I'm making the modeling system open so that if people want to know how are those predictions being made, they can know. That's the other thing I don't like about the proprietary systems is most of them are using these modeling approaches. And when you say, how are you making that prediction? They just say, trust us, it works, which is alchemy, it's not science. So anyway, so this was just the data we have. And then I was going to just ask you to, given this is the data that we have, given this is the goal that we have, how would you use that information? What kind of representation of that information would you make to support a faculty member to change their behavior? That was the task. So yeah, anybody who wants to work on that? I have a postdoc right now, Iris Howley, who did her PhD at Carnegie Mellon. And She actually already has her job, her assistant professor job lined up. So I'm losing her soon, but this is her project for right now. Anyway, thanks.
Let's thank Candace for.
And I don't just mean diversity in terms of racial, ethnic, cultural, religious, gender identity, sexual orientation, all the different usual classifications of diversity. Those are all important, but also diversity in their background knowledge, their relevant skills, and their future goals. So how many of you are teaching right now in higher education? Okay, so one of the things you may have observed is that in your classes, the students that are coming into your classes not only have varying degrees of preparation for what they need to be able to effectively do what you need them to do, so their skills are varied, but also their goals, the reason they're even sitting in that class. So we have this incredible diversity in the needs, goals, abilities of the students. The other diversity, which we study more of here at Stanford, is also the meaning that they make out of the learning experience you give them. So you can't just sort of say, if you do this, then the learner will make this meaning out of it, because that's very complex, that process. So we need to look at all of this diversity. Now, how many of you have heard about educational, I guess, infighting or arguments about what's the most effective way to teach someone something? So if you haven't heard, I'll give you a little insight into some of these arguments, because you'll hear them a lot. One of them is, when you're talking about teaching someone like, I don't know, computer science, is it better to give them some basic instruction, a lot of practice doing the basics, or is it better to give them really complex, challenging tasks so that they get a deeper conceptual understanding? Like, that's a kind of dichotomy that is often presented. So which is better?
It depends.
It depends, okay? So then once you decide,
To every social science question.
that is the answer. See, Michael knows social. It depends. So, so you might say, but you have to make a choice. Like when you're designing something, you have to make a choice. So you make a choice. Let's say you say, I'm going to give them more help with the basics. Then I have to decide, how am I going to give them help? Am I going to give them focused practice, distributed? So what I'm going to talk about today is the science of learning, technology, and transformation in higher education. So I'm going to start where I imagine good HCI people always start. Since we're talking about learning, we're going to start with the learner. So I work in I'm kind of an outlier in the Graduate School of Education, because I work in higher education. Most of my colleagues work in K-12 education. And I work not just in higher education at Stanford, but I work with institutions of higher education of all what we would call Carnegie classifications, mostly across the country, but to some extent internationally as well. And one of the things that every institution of higher education is observing is the task that we're being given, which is not only to educate more students, a larger number of students in higher education, but a greater diversity of students. Have some kind of headline, which is, she's trying to replace us with computers. And I used to respond to that in the following way. Frankly, any faculty member who can be replaced by a computer should be. But it didn't exactly have the impact I was hoping it would have. People didn't quite understand what I meant. What I meant was, what a faculty member does is so complex and nuanced that if all they're doing is what I can do with a computer, then actually they should be replaced. What I meant was also that the task that we're given as faculty to do is not doable with the current set of tools. And in higher education and other institutions where there's these increasingly constrained resources, collapsing time, collapsing resources, greater diversity of students, more students, achieve these outcomes in this different resourced environment, it's an unfair task. Unless we have repeated practice, gradually widen the practice, so I have to make that choice. Once I decide I'm going to give them help with the basic, focused practice, then what kind of practice am I going to give them? Am I going to give them worked examples to study? Am I going to give them problems to solve? Am I going to do some kind of interleave blend? And so on. I won't run you through all of this, but the point is that any choice you make quickly grows exponentially. All those little micro decisions you have to make to decide how to personalize the learning to that learner. So if you imagine, as an instructor, you're making this decision very rapidly for not just one student, but for this big diversity of students I was just talking about. So that's kind of a challenge. So what a lot of people are talking about is that our current processes for doing that, the way we've done higher education for years, doesn't really work anymore. And my argument, whenever Inside Higher Education or the Chronicle of Education or any of those newspapers write about my work, they always